Hi guys, now I'm going to show you the speeding up effect with the load on. Okay, first of all I want to show you what is going on here. So we have basically the circuit, the driving circuit, which is this transistor and these two coils, this one and this one. So these two coils are connected to this transistor, which is the driving circuit for the rotor. This is not powered by anything. Here we are going to put the load. Now the rotor is driving with another circuit, the same like this one, but only with one coil, which is this one, and here it's the Hall effect transistor, and the transistor is here. Okay, so the rotor, it's spinning only by this, not this one. Okay, and we have this is the power, the current drain that goes into this circuit. Okay, and here we have this meter is connected to this coil. This one shows us that the RPM increases or not. Okay, so we have these readings, and now we shall connect the load, which is my LED, my power LED. Let's put it here, and if you can listen, you can listen the RPM increases as well. Look, I have it connected, and it's increasing. The current goes a little bit down from 46 to 45. And once again, here we have the voltage produced by this coil, which shows us that the RPM increases. Okay, I could let it like this an hour or two, it will show the same. Let's disconnect it to see what's going on. Okay, it's disconnected. Look. We have 46 and 264. We are going to connect again. It is connected. The RPM increases and the current. Okay, this doesn't measure the current so fine, but I think there is a slight difference. Here we are, 45. Now I'm going to disconnect. The RPM decreases, and we're going to spinning up a little bit faster from my very high-tech power supply, of course. Okay, now we are going to wait to stabilize it, to stabilize the RPM. Okay, looks like it's stabilized. 283 and 55, 56. Okay, now we are going to connect. Disconnected. As you can see, the effect is happening again with the load on. Okay, I'm trying to do this this again. I'm going to disconnect. It is disconnected. 55. It has increased the current. So this is not nothing, how can I say, nothing particularly. The coils has no cores. I didn't use any capacitor, no bifilar cores, no nothing, just the coils that I made. And I'm going to study a little bit more this effect. I'm going to put the other coils, I'm going to do like this for all the other coils to see if the effect it's still there. But for now this is a very encouraging step for this. Okay, let's put it in again. Okay, I want to wait a minute. Okay, you can see the RPM increases. Another thing is, I don't know if this has anything to do with it, but I want to say it anyway. When I drive the rotor with this setup, with this setup, the rotor spins clockwise, counterclockwise, sorry. Now, I tried to spin it counterclockwise with this, and I didn't get this effect. I didn't get this effect, speeding under load. The rotor was decreasing, the RPM was decreasing. This setup here spins clockwise. Spins clockwise. I don't know if you did understand. Once again, I'm going to say it. This rotor, this setup spins the rotor counterclockwise, but this one spins it clockwise. I don't know, maybe someone will figure out what it is. Anyway, I'm going to make more tests about this thing, and I'll be posting the news. If anything goes better, I'm going to post it. Once again, I'm going to disconnect, decreasing. Okay, that's it for now. I want to see if anyone replicates this effect, to see if they get this kind of effect. Okay, that's it guys, bye bye. Hi guys, this is something interesting that I just found, and I want to show you this. Okay, we have the meter. This one only reads the RPM with a certain voltage, and here we have this coil. As you can see, it has these thin wires connected to these two, and it's not connected in any way to these driving coils. This is not connected. The driving coils are this, and this one just reads the RPM. Okay, so this coil right now we are going to short it, and let's see what happens. You can see on the meter here. As you can see, the RPM goes up when this coil is shorted, and the speed really goes up. And another funny thing, okay, we're taking off. I try to connect this one. We're going to connect it, and you can see It lights, but it doesn't behave the same. It behaves like a normal generator coil. Now we disconnected. Now I want to put this 10 ohm resistor, 10 ohm, 5 watt. I'm going to connect it. As you can see, the RPM goes down. Once again, I'm going to short the coil. The RPM goes up. Now for working this one for a working load, I have found this resistor, which is 1 ohm resistor, and with this resistor finally the RPM goes up. Okay, I'm going to disconnect it. I have here an light bulb that we are going to connect it. Now I want to show you something. Another strange thing. If you look closely, I'm going to put it near the meter. When I connect the bulb, it takes some time to become red. No? In this time, the RPM goes up. After the light bulb gets red, the RPM begins to get down, to drop. Let's see that. I don't know if you can see it, it's not so powerful, but the thing is, when it's cold, the RPM goes up, then begins to be red. Once again, now I connected, goes up and then goes down. Okay, this is what I want you to show. Once again, I want to short it. Another thing, this one, as you can see, is metal one. I tried this one with plastic, but it didn't work so well, so this one is working better. Okay, that's it for now. Bye bye.